Okay, this is Lab 3, Part 3. And so we're going to work on here. We're asked here to solve for y. So we want to get y all by itself on one side of the equation. And so 9x, that doesn't have a y on it. That's a y term. So this is a non-y term. That's a y term. And that's a non-y term. And I want to get the non-y's on one side and the y's on the other. And so I'm going to write that over here. 9x just because of room. And so this is a non-y. That's my y. This is a y term. And this is a non-y. And so you know how when you want to get them separated, you want to get you say the variable on one side and the numbers on the other. Well, I want to get them separated by y. I want to get the y on one side and everything else, the non-y's, together on the other side. So this guy's not in the correct spot. This is on the non-y side, so it's perfect. We'll call this the y side over here. So I need to move this. So remember, when you're moving this, add and subtract are the ways of moving it. So I'm going to take away 9x. I'm going to not like terms here. So I'm going to line it up here, take away 9x. Now it's my choice whether I write this as 12 take away 9x here on that side equals minus 4y, or if I write this as minus 4y, that's what I had over here, and instead put this before and write this as negative 9x, and then it would be plus 12. My choice on which one I do. In algebra, typically, when you solve for y, you typically write your x first. But makes students happier to write sometimes the x second. And this is what you sometimes would do in statistics. Anyway, so either way, you get equivalent answer. So now I'm going to divide by negative 4. Put your finger on y and divide by what you see. So negative 4, and you got to do that to all. So you got to divide by negative 4 here. You got to distribute it. Divide by negative 4 here. And of course, if you were doing this one, then you would have negative 4, and you're going to see that it's going to be really similar answer here. So here I'll have y. 12 divided by negative 4 is negative 3. A negative divided by a negative is a positive. 9 and 4 don't reduce. 9x over 4, right? Here, if this is what I had, that's my answer there. This is y. A negative divided by a negative is a positive, so 9x over 4. And then I have a positive divided by a negative, and I can write that as a subtract of 3. So they're the same. Now both of these, if you liked, you could write 9/4 x as a fraction. 9/4 x is the same on those, your choice on that. And that's what they're going to write in the back of the book. So they're going to write y equals 9/4 x minus 3. That's probably what you would find in the back of the book. Now number 17 says that x is negative 3, v is 5, and d is 7, and they want me to find a. And so this is an equation that has 4 variables in it, but 3 of them are known. And so I'll be able to find the 4th just by plugging in here. So where I have x, I'm going to put parentheses squared. And what did they say to put in for x? Negative 3. And where I have v, I'm going to put parentheses squared. You remember you changed the variable out for parentheses and then put the number right in there, 5. Plus 2, I don't know what a is, and then parentheses d. What did they say d was? 7. So this is negative 3 squared, that's 9. 5 squared is 25. And then this, because of the commutative property of multiplication, is the same as 2 times 7 times a. And I could write it in whatever order I wanted. And so that's 14a. So plus 14a. And all of a sudden, it's not too hard to solve for a, right? There's no like terms to combine. We did all that multiplication and whatnot. Now we're on take away 25 from both sides. So we get negative 16 equals 14a. Is 9 take away 25, 16, negative 16? I got to make sure of that. And yes, and so I'm going to divide by 14. Put my finger on a, divide by what I see. And so this will reduce right? So my answer for A is going to be 8 over 7, negative 8 over 7. So I divided out 2 in the top and 2 in the bottom, so I reduced it. So we did a lovely job on that. This is a problem from 1.8, I believe it is 1.8. And so they have the inequality, but you go just like you were going for with if it had been equals. So I want to get the variable on one side and the numbers on the other. And it doesn't matter what side you put things on. So I could put the variables over here. That's typically what I would do. So I would probably add 2x to both sides and take away 9. So when the dust clears, I have 5x, the same symbol. And what do I got there? 6, negative 6. And then I'm going to divide by, be dividing by 5. And when you divide by a positive, so I'm going to divide, this is when you have to be careful, because this is where things change different than when it's equals. When you divide by 5, which is positive, there's no change to the symbol. So I'm going to divide by 5. 5 is positive, no change to the symbol. So x is greater than negative 6 over 5. This is set notation. This is my answer in set notation. They also show us some fancy set notation. And I don't remember if they did that in your book in 1.8. And I'm going to look right now to make sure. Or if they just did the fancy notation later on in the book. And so that we'll be all on the same page. And I think it's that they show us that fancier notation later on in the book. And I'm right on that. So I'm not even going to worry about it. So there it is right there. Set notation. So this goes right here. X is greater than negative 6 over 5. Now they want me to put this on my number line. And so here's 0. So negative is over here. Negative 6 over 5. Because it's inequality and not equals, you use open circle to show that it doesn't include negative 6 over 5. So I use an open circle. And my answers, my solutions are bigger than, not including negative 6 over 5, but bigger than. And the bigger thans are this way. So there's my graph of it. Okay, so we're going to do another one here, number 18. And we're getting there, slowly but surely, right? I hope I pushed record. I did. I've done that before. Oh my gosh, there was almost tears. And so here, all I have is the last step, which is divide. And I'm going to have to divide by negative 14. And when you divide by a negative, that's when you have to flip the inequality symbol. So if it's going this way, I guess it's or equal to, then you flip it over and it's now going that way, right? So you just flip it. And so I say to myself, I'm going to divide by negative 14. I'm going to divide by negative 14. And I tell myself, flip. So this is going to be x. And then the symbol is going to go the other way. So instead of being the greater than or equal to symbol, it's going to be the less than or equal to symbol. And then I just have to reduce negative 70 over negative 14. I think that goes evenly. Actually, it does. If it didn't, it would be okay. But it does. It's 5, right? A negative divided by a negative is a positive, so 5. So there's my set notation. X is less than or equal to 5. And then I'm going to put this here on my number line. So here's 5. And because it's less than or equal to or greater than or equal to, you use a solid circle because it includes 5 as the answer. So my answers include 5, but are smaller than 5 as well. So I have infinitely many answers. One of my answers is 5, and all the rest of my answers are smaller than 5. So anyway, so there's my answers there. Then I have some lovely word problems. Isabel got 84 out of 92 on her biology midterm. What percentage of the problems did she answer correctly? Round to the nearest 0.1%. So we talked about a problem like this in class where it's your points divided by the total points times 100%. Do you guys remember that to turn it into her percent? So her percent that we're looking at are going to be Isabel's, her points, right, over the total times 100%. So that's my thought, is what is going to give us our answer. So this is going to be 84 over 92 times 100%. And this is what I plan on putting in my calculator. So 84, and then this calculator won't do that, so I have to push it again. 8492 times 100. And of course it gives me me as a fraction, so I have to push my S to D to turn it into a decimal. So 91.30, and it said tenth. So I have to know my place value, 91.3, that's the tenth. I don't want anything after that spot. So I either want to leave that a 3 or I want to bump it up to a 4. And what determines what I do is the next digit. Because it's under 5, it's 0, I would truncate, I leave it. And so it's 91.3% is what Isabel has got on her biology midterm. Okay. So while shopping in Boise, Idaho, Giovanna found a pair of pants that were regularly $35. The pants were on sale, 25% off, including 6% sales tax. How much did the pants cost? Also remember to round appropriate for money as you go along. I wouldn't have had to tell you that, this part, because it is money. You should know that. So I was just reinforcing that. This seems really similar to a problem that we had in class on our lab 2. But maybe the numbers are slightly different. I mean, it seems like there was a discount, right? So that's the first thing, is to find the discount. So the discount is your percentage, which is 25% that we're going to remove, times the price of the pants regularly, which is $35. So this is going to be the discount that Giovanna is going to get on these pants if she buys them. $8.75. Those were the same numbers. I was remembering, right? And then the sell price for these pants is the regular price, $35, minus the discount, $8.75. And there is a way of doing this all in one step, and I'm fine with you doing it. The reason I'm doing it this way is because this is how the book does it, and in math, there's a lot of times different ways of going. So $35, take away $8.75, and of course this calculator says, you know, let me give it to you as a fraction, but I don't want a fraction. So that's $26.25, and that's just the price of the pants, right? And now I've got to pay Idaho Sales Tax, which is 6% in Boise, Idaho. I wonder if I look that up, that sounds like me, and look that up. You know, I don't know if I did. And so I just want to find the tax. So the sales tax. And so the percentage is 6%, so that's 0.06 times the price of the pants, $26.25. And so I'm going to be paying basically 6 cents on the dollar, right? That's what 6% sales tax means. And I got $26.25. So my sales tax is $1,575, but this needs to be money, friends. And so this is the first thing that didn't come out money, right? This is more digits than money. There's money right there, 57 cents. But the next number is a 5. So that means that I'm going to have to, because there's my hundredths place, right? My pennies place. So I'm going to have to move that up 1. So I'm going to have to go up 1 there because this number is a 5. So I have to bump that up. So this is going to be $1.58 in sales tax going to the great state of Idaho. And so now my total, finally, the things I'm going to pay, $26.25 for the pants, $1.58 for the sales tax. And so to me, $26.25 for the pants, $1.58 for the privilege of buying the pants. S to D is $27.83. So I'm going to pay $27.83 for those pants. If you think, well, that was different than the one in class that we did on the lab, but it was slightly different numbers. These numbers were the same, but that number was different because the pants were bought in California. On the last problem, these were bought in Idaho. Okay, Abby has a bunch of coins. She decides to use coins to buy the calculator that she needs for her math class. She decides that using the self-checkout line will be perfect because she can simply insert the coins one at a time, and the machine will keep a running total for her. She has pennies, nickels, dimes, and quarters. And as she puts the coins into the machine, she notices that she has inserted the same number of pennies as nickels. So I'm going to just write here a note to myself. The number of pennies equals the number of nickels. That's what they just told me there. Okay. And let's see what else. And remember, a penny is worth 1 cent and a nickel is worth 5 cents, right? Okay, what else does it say? Had to do some coughing there. Might have to get some tea. And that she inserted 11 more dimes than nickels. So we know that the dimes equal the nickels. Remember, I use lowercase d for me, plus 11. Because there are 11 more dimes than there are nickels. So if she had 1 nickel, that means she would have 1 penny. And she would have 12, 1 plus 11, 12 dimes. And 11 more dimes, right? She also notices that she inserted exactly $9 in quarters. So that just wipes the quarters out. Do you guys agree? You could figure out how many quarters that is right away if you wanted, because it's going to ask that. But $9 in quarters. And that is 9 times 4, right? That's 36 quarters. So I don't really have to worry about the quarters anymore. I can come down here and say 36 quarters, right? Because they told me the quarters. If the calculator costs $13.14, including tax, how many of each coin did she pay with? So we're going to have this set up, right? 1 cent times the number of pennies plus 5 cents times the number of nickels plus 10 cents times the number of dimes plus, and then on the quarters, since they told me it was $9 and I already know there are 36, it would look really funny because I could go 25, right? Because that's what it's worth, times 36, and then that should end up being $9 or 900 pennies, if you like. And so I am going to put, I have this in cents, I have this in cents, I have this in cents. My plan is to put $9 here. This is in dollars, and I'm going to fix it. Don't worry. So if you're saying, fix it now, I will. And then $13, that's what this equals, right? So you can't have mixed units. And so you have to convert these either into cents, they're already in cents, sorry, into dollars, or these into cents. And I would prefer to convert those into cents, and I get to make the decision, right? So this is 1 penny plus, I don't want to write all of this because I have some converting to do, all this converting to do. I'm going to do all at one time. So this is going to be 900 cents. And this is going to be 13.14 cents. Whoops. I was getting rid of my decimal point, and then I didn't get rid of my decimal point. Okay, so this converted now everything into cents. Now the dimes, remember they were n plus 11. So this is, my converting here is n plus 11. And my nickels, well, see how I already have an n going here? My nickels, I'm going to leave them alone, 5n. And then my pennies, I want to convert them into nickels because it looks like I'm going to have everything in nickels. So you want to try to get everything in one variable, and this one came out pretty nicely. That was pretty easy to get it all in nickels. So now I'm just ready to solve it. 1n plus 5n plus 10n, so I'm distributing, plus 110 plus 900 equals 1314. So when I add those together and add these together, that's 16n. And let's see, is that 1010? Equals 1314. And then I'm going to subtract 1010. So I have 16n equals 1314 minus 1010, 304. And I'm going to divide that by 16. And if that doesn't give me an even number, because it's supposed to be the number of nickels, then that tells me that I made a mistake somewhere. So I was helping someone with their problem from XYZ, and very similar problem actually. Everything boiled down to nickels on it too, coincidentally, and we kept getting a decimal for our nickels, and I was pretty sure we had it set up right. But then I noticed that when we distributed, that we had made a multiplication error, and then we got that fixed, and then we had an adding error. I mean, it was just crazy. It can happen. So we have 19 nickels. Now we have the same number of nickels as pennies, so if we have 19 nickels, we have 19 pennies. And we have 11 more dimes than nickels. So this right here is going to be 19 plus 11, which is 30 dimes. So she paid for her calculator in coins, 19 pennies, 19 nickels, 30 dimes, and 36 quarters. And you could add this money up and make sure that it's 1314, because it should be. And I've done this problem, so I'm gonna go on without adding it up, but I know that it adds up. Okay. When Kevin arrived at the cabin, the temperature was -5 degrees Fahrenheit, and it was very cold. So he turned on the heater and he built a warm fire, and after a while he noticed that the temperature had risen to 11 degrees Fahrenheit. By how much did the temperature change? So it's still 11 degrees Fahrenheit, still pretty cold, right? But it's better than it was. And here's my thermometer, and here's where 0 is, 0 degrees Fahrenheit on my thermometer. And then he started off here at -5 degrees Fahrenheit. That's where he started. And when he ended, doesn't have to be to scale, but I'm kind of tried to make it look a little bit to scale. It was 11 degrees Fahrenheit, and so the temperature had risen this amount. So you can see, just to go from -5 to 0, it was up 5 degrees Fahrenheit. And then to go from 0 to 11, it was up 11 more. So altogether, it was up 16, right? So 16 degrees Fahrenheit. So by how much did the temperature change? I'm going to say that it went up 16 degrees Fahrenheit. And then when all teams, we had one similar to this too, right, on a lab. And so not exactly the same numbers, but, you know, a similar idea that it really helps to draw this lovely thermometer. And so when all N teams in a league play each other twice, a total of capital N games are played, where here's your formula. Capital N equals N squared minus N. If a bowling league has 7 teams, so when I read this, I think, is that capital N or lowercase n? So let's see. Lowercase n is what tells us what the teams are. So right here, as I read that, I realized, hey, they gave me a formula. So they're going to start giving me the pieces of the formula. So right when I read 7 teams, I wondered, did they give me capital N or did they give me lowercase n? And lowercase n is the number of teams. So 7 teams is that. And then now what they're going to ask me is, how many games will be played if they play each other twice? And this formula will give you that, right? So notice the next thing they ask is for how many games will be played. And this formula, N, stands for the number of games that would be played. So N equals, and then this is, I'm going to fill in the blank here, squared minus N, right? But we know that little n is 7. So 7's going right in there. So actually not much work to solve for N at all. All you have to do is do that arithmetic. So this is 49, take away 7, which is 42. So they'll play 42 games. So that's kind of how that would go. You could count them up if you wanted to. That would be a way of going and as well. And so you could get clever about it. And so the formula is much better, of course, but just to show you, because people say, well, how could it be 42 games? But just to show you, if I had teams and I named them, I have 7 of them. So let's see, A, B, C, D, E, F, G, 1, 2, 3, 4, 5, 6, 7. So there's my 7 teams, right? And I named them A through G. And we know that A and B are going to play each other twice, so that'd be 2 games. And A and C are going to play each other 2 games. And A and D are going to play each other 2 games, right? And this is going to continue until A and G play each other 2 games. So games that just involve A are going to be, do you guys agree? 2, 4, 6, 8, 10, 12, if I had written them all out and counted them, right? And then now that's all the games that are going to include A playing. And now we're going to have B playing. And I'm not going to include A because B's already played A, the 2 games they're going to play. So B is going to play C, 2 games. B is going to play D, 2 games. And on this would go until B and G play each other 2 games. And when I count that up, right, 2, 4, 6, 8, 10. It's going to be 10 games. So already we're at 22 games of the 42 that this formula is counted up. And you can continue in this process. And when you do continue in this process and then you add all these games up, you'll notice it's 42. So the next step would be C and D playing each other, C and E, C and F, right? And if you count up those games, guess how many that's going to be? It's going to be 8, right? 2 games here, 2 games here, 2 games here, C and G, right? Going to be 8. And then it would be D and E, and D and F, D and G, etc. And so etc. And so you can verify. So that would be a way of figuring out this problem besides using that formula. Of course, the formula was easier. Okay, 25, and then we're done. $3.99 is the regular price of a Roomba vacuum cleaner at the Costco. If the vacuum is now $50 off, I almost read 50% off, but it's $50 off, different than 50% off. 50% off would be a lot better, but $50 off, it's asking what is the percent decrease of the vacuum cleaner round to the nearest 1/10%. So there's a formula in your book for percent decrease. And it goes like this. I can't remember what section it's in, but it's the change, and you want that in the change in price in this case, and you want this to be positive. So sometimes they give you the new price and the old price. This time they just told you it was $50 off, so they actually just told you the change in price. But you want this to be positive, divided by the original price. At times 100%. So in our case, the change in price was $50 because it's $50 off, right? They could have told me that the new price, you know, the old price, the regular price, the original price was $3.99, and they could have told me, which they didn't, but they could have told me now it's on sale for $349.99. That's $50 off. And then I could have done the subtraction to find the 50. But here they just told me the change here. And I want that to be positive, so that's why the absolute value around it is to make it positive. And then the original price is $399.99, and then times 100%. And then I'm just going to do that little arithmetic right there, and then that will be our percent decrease for our Roomba vacuum cleaner. So times 100, don't put the percent sign in there because you want it to be percent. And I got 12.5, and then it went 0, 0, da 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 da. But I don't care about those because it said tenth, right? And so now I have it as a percent, right? And it said tenth of the percent. So once you get it as a percent, you want to round to the tenth. So there's the tenth place right there. So I want to end here, but I look over here to decide, am I going to bump up to a 6 or am I going to leave it a 5? I'm going to leave it a 5 because that next number is only a 0. So 12.5% is the percent decrease. So if they were going to advertise it, instead of advertising it as 50% off, or 50% off, $50 off, sorry, I keep saying 50% off, and people are going to be rushing down to Costco to get that vacuum cleaner, right? They could have said it's 12.5% off. And obviously it looks better when they say it's $50 off on that. Okay, so that's my story on those problems. I'm going to get this up on YouTube for you guys, and I hope you're having happy studying.